Can you imagine coming in to your office and staring at the same thing every day for 2.5 years, trying to refine it little bit by little bit, and it would change, I don't know.
It changed by one letter. I would add one letter to
one letter every couple of months, right? Or something.
To my little table.
It's crazy, right?
There you hear Fred Ramsdell and Mary Brunkow talking about just how slowly research proceeds sometimes.
It's good that they at least seem to enjoy each other's company, even though they had a quite hard time doing their science together.
They did indeed. They obviously grew together in adversity, but they got there. And what's interesting is that we're talking to them together as well as separately. For the first time, we've got two people who worked together closely at the time of their research speaking together in the podcast, which is fun.
You can tell that they've known each other for a very long time.
Indeed. And of course, we also spoke to Shimon Sakaguchi, their co-laureate. Can you imagine staring at the same thing every day for 2.5 years and it changing little bit by little bit? That sounds like most things in my life, really.
You're listening to Nobel Prize Conversations. I'm Karin Svensson.
I'm Adam Smith.
And this podcast was produced in cooperation with Fundación Ramón Areces. Let's start with an introduction to our two paired laureates. Mary Brunkow was born in Portland, Oregon. Her grandfather was a surgeon, and as a child she dreamt about practicing medicine herself one day. She wanted to help people. Starting out at a time when scientists were just learning to read the body's genetic code, she found her calling as a geneticist, hunting down the causes of deadly autoimmune diseases. She continues to be driven by her desire to help and support others, in work and in life. Fred Ramsdell was Mary Brunkow's colleague at the biotech company Darwin Molecular, where they made their breakthrough in peripheral immune tolerance. Growing up in what would become Silicon Valley, Ramsdell became the first in his family to go to college. He thought he might spend his career on a stage or a soccer pitch before realizing his place was in the lab as an immunologist.
I've heard you say that science was actually your fallback career when you were young.
Well, as a young individual, I had a hard time figuring out what I wanted to do with myself and my life. So I was really pretty good at soccer, but not good enough to make a living at it. I was a decent actor, but I couldn't sing or dance. So that was going to be pretty career limiting. And I always liked science. I think the curiosity of science was always something that was really important to me. So yes, I spent a semester as a theater major. That did not work out. Best for all concerned. And then I thought I was going to go to medical school until I got close to going to medical school and thought, I don't really want to do this. Science is more interesting to me. And to be honest, most of the people I know who were pre-med were just not that enjoyable to be around at the time. And I didn't want to spend 4 years in college with people I didn't really enjoy. So it's either graduate school or get a job, and I didn't want to get a job. That seemed like a terrible idea. So let's defer this for another 4 years and go to graduate school. Yeah.
It's a good sign that you really are bitten by the bug, isn't it? That you turn away from medical school into research.
Absolutely. But it is really a different mindset. There are people who are great physicians and great physician scientists, but it's really a different way of thinking about the world.
Were there particular people who taught you how to do good research?
There certainly were. So, I think just my upbringing in general fostered a strong work ethic. But in particular, during my undergraduate days at University of Washington, I had the great pleasure of being able to do an undergraduate research project in the lab of Dr. Larry Sandler, who was a kind of classical fruit fly geneticist. His method of teaching and mentoring were so rigorous, and it's a field that sort of lends itself to real rigor, I guess. It's real hardcore genetics, which doesn't lie. There's no other way to interpret, really. You have to be smart and clever in designing an experiment, but then what you get out of it is it explains what's really happening.
Yeah.
And I guess he taught me that. And he had some really talented graduate students and postdocs in that lab who influenced me a lot. And then my PhD mentor as well, Shirley Tillman at Princeton, is such a gifted scientist herself and such a nimble thinker. and interpreter of, observations. And she really instilled in her grad students and postdocs a real rigor to looking at the data and trying to erase all your preconceived biases and just look at the data and figure out how to interpret it anew and then write it up. But, communication was also really important to her as well. And so I would say between the two of them, I felt like I was very well launched into the world of research, which was a real turn because I thought I wanted to go to medical school, all up until my last year in university. But working in Dr. Sandler's lab showed me, I never even considered research ever. I didn't even know it was like a thing. But I went, the minute I stepped in his lab, it was like, wow, this is very cool.
Your redirection from medicine, you share that in common with Fred, but also the way you just spoke about it was exactly the way that Ardem Pataputian, who got the Nobel Prize for touch receptors, it was exactly the way he talked about that conversion from thinking he was going to be a doctor to finding that he just couldn't resist research.
Yeah, I think that's what I always really found attractive about genetics is the logic behind it. Biology is so complex and so kind of squishy. I feel like there's a lot of stochasticity probably involved in, biological processes. But genetics is measurable. You're not always going to figure it out, but in the end, it explains so much in a logical way.
Are we hearing a pattern here, Adam? Starting out with a plan to practice medicine and then being seduced by research?
Yes, I think that's often the path. But more generally, I think starting out on anything and then being seduced by research is a common thing that happens to laureates. It's suddenly being exposed to this possibility to explore some question in great detail and to play with it and to go down that particular rabbit hole. You hear many laureates, many scientists talk about this moment that they realise that actually, research is really a chance to explore the unknown and get very close, very quickly, to the forefront of knowledge. That is what seduces them.
Are there many examples like this of Nobel laureates who were first heading towards becoming doctors in medicine and then falling down the rabbit hole?
There are many. People who spring to mind, Ardem Pataputian, who discovered touch receptors. He was setting out to become a doctor at UCLA, and I don't think he was really enjoying the path to becoming a doctor all that much, or at least he wasn't enjoying the lab work that was involved. But he had to get a position in a research lab in order to get somebody to write him a reference. So grudgingly, he looked around for one, found one, and then when he got there, thought the world had just opened up to him, and suddenly there was this entirely new thing he could do. He abandoned medicine and went after research. Another one is Bruce Beutler, another immunologist like our 2025 laureates. He did medicine and practice for a short time, but then decided to concentrate entirely on research. In his case, though, it was a bit different because he was a very rare example of having been exposed at a very young age, as a teenager, to the joys of research in his dad's lab. And so he knew what it was to explore the unknown, and he was always determined to do it, and therefore he went into medicine knowing that he wasn't going to do it full-time forever. The reason he did that was that he understood just how much medicine can give you as a general overview of biology and how things work. And he wanted that as a basis for his research.
I wonder if the medical profession thinks this is a good idea to lose all these people.
I don't know. I guess they give back to the medical profession in the long run by discovering things. Obviously, to be a good doctor is an amazingly difficult thing to be, and to know enough that you can recognise and act accordingly, recognise what's wrong, do the right thing if it's available. That's not easy. So that is entirely fulfilling for most. But for some, they just are more switched on by having one particular thing that they really need to know about. And I suppose medicine attracts, it's a difficult degree to get into. It attracts very bright people. And some of those bright people haven't seen that side of themselves before. So if they're brave enough to grab it when they see it, the research might hook them along the way.
Our third laureate, Shimon Sakaguchi, was also on the path of becoming a doctor before he was hooked on science. And we'll hear him talk about that in a moment, but let's give him a proper introduction first. For more than 2 decades, Shimon Sakaguchi refused to let go of one particular idea, even when most other immunologists considered it a dead end. he doggedly continued to conduct his experiments in his native Japan and later at Stanford and Johns Hopkins in the US. It was an idea whose time would eventually come and net him a Nobel Prize.
So I graduated from the medical school and then got into the department of pathology to get the PhD. But it was not so interesting to me to become a pathologist, autopsies and then diagnosis by microscope, something. And then still I was interested in autoimmune disease. I looked for a good system for studying autoimmune disease. And then I came upon with that finding, that is, neonatal thymectomy can somehow induce autoimmune-like disease. That was why I got interested in this particular experimental system.
It's fascinating that you were so hooked by the problem that you just couldn't let it go. And that's often the way, of course, that we see in great scientists and Nobel laureates, that something just somehow attracts them and that's the problem for them. What did your family feel? Because you come from a long line of doctors, so did they expect you to become a practicing medical doctor?
Well, actually, my father, he was the director of the municipal library. And before then, he was a teacher in high school. So he majored philosophy. My mother, she came from the family and rural doctors. So I was familiar with the medical doctors, their jobs. But somehow more my father's influence to think about some contribution to science and not medical practice. So in retrospect, perhaps somehow I was influenced by the way of life, my father's. So the various ways of contribution to medicine and medical practice, but also decipher the mechanism of diseases and then find out the way of preventing or treating disease. So I chose the latter approach. I also thought that I'm not so good at doing research. Well, then I'll go back home and then become rural doctor. So kind of fail-safe type way of life.
Yes, and being a rural doctor isn't such a bad life, for sure, yes. It's interesting to hear you talk about your father's interest in philosophy and how that influenced you, because, of course, scientists very frequently talk about how learning the practice of science drew them into it, but less so talking about how the practice of philosophy drew them into science. Could you talk a little bit more about that? What did you pick up from your father? How does philosophy influence your approach to research?
Well, it's hard to tell. Perhaps not philosophy, but a way of life. So my father, he was recruited to the army during the World War II. He could speak French because he majored Western philosophy. And he was sent to Indochina, now Vietnam, because he could speak French. But he couldn't come back to the university when the war ended. Because of malnutrition, he must anyway come back home and then recover. So he started his life as a high school teacher. But he also wanted to work or study in university. Perhaps that hope influenced me. He wanted me to do something what he couldn't do because of the war. So perhaps in retrospect, I recently talked to my brothers. They all suggested me that you are very much influenced by my father. Somehow you are controlled to take that direction.
Did it ever cross your mind that it was a mistake, or did you think, I know what I'm doing?
Perhaps not, because it was mid-1970s. So the kind of turmoil in the universities, anti-government, that kind of student power, that was until early 1970s. And at that time in Japanese universities, so a normal course, well, usually the student, okay, I graduate from the school and then go to the PhD course and then step by step going upward to get the position. That kind of order was a bit disturbed. And then people thought that, well, you are more kind of free in your decision. So that was the atmosphere at that time. So what is important, what is good for you, that kind of decision is, I think it's broader than now.
Oh, really? So this was a more permissive time for novel ideas, if you like.
Well, and also the authority, the university a bit affected at that time, everywhere in the world. So you can take a normal course, but also you can take whatever you want, do whatever you want to do. So that was a kind of an atmosphere. But if I were born now and then go to the university, and then perhaps the society is so static or more ordered, and so I may taken a usual course to become a scholar or a scientist. So it depends on the time when you live or happen to live.
So let's get to the heart of the science behind this year's Nobel Prize in Medicine. It started with a discovery by Shimon Sakaguchi, didn't it?
It did indeed. This is immunology, so nothing's ever simple.
Well, I'll brace myself.
Me too. So his discovery was these things called regulatory T cells, which are a subset of things called T cells. And they are responsible for maintaining what's called peripheral tolerance in the immune system, which basically means an extra layer of protection that teaches the immune system not to attack you. The immune system has this wonderful ability to recognize you as opposed to non-you. Most of the time, except when it goes wrong in various autoimmune diseases, it's very good at that, and your own immune system doesn't attack your body. But in order to learn not to do that, it has to go through some steps. And the initial step happens in your thymus, which is in your chest, where things called T cells are basically taught the difference between non-you and you. That system isn't perfect, and so then there has to be a second layer of control, if you like. And that control is mediated by these T regulatory cells that were discovered by Shimon Sakaguchi. He solved a question which had been out there for some time that people had just got very confused by. And he came up with a very elegant way of identifying that there must be a group of T cells that was responsible for this, and then a way of identifying the particular group of T cells that mattered. And it took him a long time, but when he got there, it was absolutely revolutionary because it solved this long-standing problem.
So how did that get picked up by his co-laureates?
Well, for that we have to think a bit more about what Sakaguchi did. He'd been intrigued by an observation made by some other Japanese scientists previously. So T cells mature in this thing called the thymus. And these other researchers had removed the thymus from very young mice. And the expectation would be that if you did that, you'd stop the T cells maturation, you'd remove a large population of them. The immune system would therefore be weaker.
Right.
But when they did it at 3 days, they found that the immune system overreacted hugely and there was a big autoimmune reaction and the mice died. And he was fascinated by this and thought this finding might be a key to working out more about how tolerance works. And he identified the fact that it was a subset of T cells that were responsible. Now, Ramsdell and Brunkow had noticed that the phenotype of those mice was similar to the phenotype of a mouse called the scurfy mouse, which was a line of mice being kept alive in a mouse breeding facility in Tennessee, which had an odd phenotype, which was that half of the male offspring died of autoimmune disease. And it was an interesting enough finding that somebody had had the good sense to keep this mouse line running and bred it through generation after generation. And Ramsdell and Brunkow set out to discover what gene was responsible for this strange mutation. They knew it was on the X chromosome because it was only in the male mice. And they dug and dug and dug, and eventually they identified the relevant mutation in an unknown gene, which they called FOXP3. And that FOXP3 gene turned out to be important.
And why was it an important discovery?
Well, for starters, it's important because it fundamentally changed our understanding of the immune system and how it works. And that is, in some ways, enough. That's pretty good. It also has therapeutic implications. For one, it's an important finding if you're seeking to treat autoimmune diseases, especially those, of course, that come from misfunction of regulatory T cells. It's good to know that they exist and where they come from. But then regulatory T cells are also involved in other diseases, in cancer, for instance. Cancers do well if they can protect themselves from the effects of your immune system. And one way of doing that is to surround themselves with regulatory T cells, which can somehow trick the immune system into thinking that the cancer is not to be attacked, that it's self, not non-self. So understanding more about these cells and their creation and their behavior is an important way in to thinking about how to make cancers more susceptible to immune attack.
You should just have led with it can treat cancer.
I see what you mean. Oh, yes. There we are. That's such an important point because I suppose you're right in some ways. That's what people want to hear. And that's what, for many, it's all about. But one shouldn't lose sight of the fact that it's tremendously important just to increase our fundamental understanding of how things work. It puts another piece into the extraordinarily complex puzzle of the immune system. And that in itself is pretty good.
Yes.
Let's listen to Fred Ramsdell and Mary Brunkow reminisce about just how hard that work was that preceded their discovery.
How long did you stare at that thing on your wall?
I think 2.5 years, something like that.
So she had a map on her wall that kept changing every so often.
Yeah.
And can you imagine coming into your office and staring at the same thing every day for 2.5 years, trying to refine it little bit by little bit, and it would change, I don't know, once
Changed by one letter. I would add one letter to the
every couple of months, right?
To
or something.
the little table.
I mean, it's crazy, right?
Yeah.
Yes, it sounds Herculean as a task, but I suppose you're focusing in and in and in. There is at least the sense of getting closer, if you're right.
Yeah. Sometimes I felt like I was making a mistake in trying to stay on top of the literature. There were other groups who were trying to map the X chromosome, both in human and in mouse, and trying to reconcile those maps with what we were finding was really, that was challenging. And in a way, as I recall, the information I was getting from those other publications more often than not led me in the wrong direction. And if I had just focused on, our own little internal mapping experiment, it might have gone smoother. I don't know. Those were crazy times because there was so much excitement about generating, full genome sequence and really understanding the structure of chromosomes and also understanding the synteny between human and mouse chromosomes. And, there was a lot of work that was happening at the time, but it was so incomplete, but people were still, publishing what they could as soon as they could. And it was helpful for getting new markers for the region, but overall getting the sense of the overall gene content and gene order was often confusing.
Was there a sense of being very much in competition with other groups that were trying to get there? Were you worried that you were going to get scooped?
Yeah. Fred had very close knowledge of what was going on at least one place.
Yeah, but I also knew how good they were. And they were motivated as well. They're very talented people. And they took a different approach. I don't know why it didn't work for them, but it didn't. I actually remember riding home on the ferry one day after we had identified the mutation. And I got one of them on the ferry and said, so I just want you to know we got the gene. And he looked at me and he said, really? And I said, yeah. He said, what is it? And I said, I'm not going to tell you. But I said, I will tell you once we have a confidentiality thing going, but I'm not going to tell you today. But I don't want you to waste your time doing this. It's stupid. It's useless at this point, unless you've already got it and you didn't tell me. And he looked at me and he just said, is it a transcription factor? And I said, I'm not going to tell you. And I walked down and got on my bike and thought, how did he know that? This is crazy. But he did. So we knew they were working on it and they were going really hard. And I remember we got them in. Mary walked through how we got there and they were just like, I don't want to know. Just tell me the name of the gene. Just tell me what it is, And so we did. And it was, they're still friends. So that's good.
I guess your acting training came in when he asked you if it was a transcription factor. He was probably looking deep into your eyes to get a glint.
Yeah.
You've touched on the underlying scientific excitement of the moment, of the times. I suppose it's almost impossible to define what made that team so good, because if you could, everyone would replicate it all the time.
Right.
But can you try? What was right?
Well, I think the leadership was right. The David Gallis influence over the company was right. I think we were really lucky. There was a really strong core group of people, Fred, that came from Immunex, which I felt like kind of set the tone and kind of set the work ethic and the enthusiasm level. But then there were a lot of other really great people that some came from the University of Washington. There was a good mix of people who came from academic and company experience.
It is true, though. In other places where we've done something resembling a startup, I've tried to employ this to some level of success, which is bring in people you've worked with before so you know their work ethic, their capabilities, their flaws, all of that, but they're experienced people as well. It's not their first rodeo, as we like to say. So you can do things quickly and flexibly. And I'll give you an example. We at one point had to do this experiment where you need 2 different people's blood. And there were about 10 of us in the company at this point in time. And so Tom Cox, who was the research associate who worked for me, and I were like 2 of the only people in the immunology lab, I think, at that point. So, he had blood and I had blood. So he bled me and I bled him. In the office, no walls. We didn't have walls at this point. It was just a bunch of tables sitting out in the middle of this space. Neither of us is a trained phlebotomist. We have bled people before. And at one point I thought, it's got to be against some HR policy to bleed your employee. But, we just looked at each other and went, well, I'll draw you, you draw me, and then we'll get going. That's the kind of attitude and environment you try to foster. And you can only do that with people you have a great relationship with and you trust. And so I think we started out with that kind of level of trust. And that just helps build this great, because other people come in and see that. And so I think that just sets the culture in the right direction.
That's a really good story. Yeah, who wouldn't want to be
Giving their blood draw.
part of a company where people are taking your blood? No.
That was a bold admission.
I know. I don't know how many laws I broke, but whatever.
I know, you have nothing to lose.
The statute of limitations has to be over by now.
So what does this Nobel Prize say about the interplay between doing research in universities and in biotech companies?
Well, when it works, doesn't it? As in this case. I suppose if you look at what this one says, it says that you can do great work wherever you're best suited to be. Sakaguchi works in academia and that suits him. And at the time of this discovery, Ramsdell and Brunkow were working in a biotech company and that really suited them. So often when young people ask scientists, ask Nobel laureates, where should I work? The answer is, well, wherever you feel most happy, most comfortable. It's pretty obvious, really.
As in any profession, I guess.
Yes. Ideally, it's a no-brainer. There should be a lovely integration between the two, that academia, it's a bit easier to dig deep into fundamental questions which don't have an obvious application straight away. In industry, there's less time for that, and it's more about looking at things that are coming out of the research community and using those and then contributing to them and doing experiments that can't be done elsewhere for various reasons, but also having an eye on how to apply it in a way that could never happen in academia. I mean, for instance, in drug discovery, there are lots of academic drug discovery departments, but it's at some point it becomes very hard, certainly if you're looking at a disease in a big population, to develop a drug for that population if you haven't got industrial support.
Right.
And there are lots of people who flip between the two. And there's even our old favourite Eric Betzig, who got the chemistry prize, for developing a microscope that he found he couldn't develop in academia because he didn't like it there, and he couldn't develop it in industry because he didn't like it there. So he ended up developing it in his friend's front room.
No, just as long as it works, then.
Exactly. Be where you're happy.
Let's listen to what the laureates say on this. And first we'll hear Shimon Sakaguchi give his outside perspective of the value of research in biotech companies. And then Fred Ramsdell will act as our resident insider.
My fellow laureates, they worked in the biotech company. But I was very much fascinated that they thought that the one gene defect can cause the autoimmune disease, very severe allergy, and also inflammatory bowel disease. So just one gene. So they thought perhaps that if they characterize that gene, and then perhaps if it's druggable, then they can find out new ways of treating not only autoimmune disease, but also allergy and then inflammatory bowel disease. It's very challenging. But they did that in biotech company, very ambitious endeavor. So that was amazing. And then it seems to me it's a kind of strength of the science in the United States. The academia and then also in industry, they can be very much challenging. They can challenge something they think it's important in medicine. In Japan or other countries, I think pure science, it's good. But also, if you have some vigor, something stimulus in medicine, you can have them from the real disease or clinics. Good example is the Peter Medawar. When you read his autobiography, he was interested in, he got involved in immune tolerance. So because during the World War II, that the soldiers, they are burned, they did a skin graft. At that time, skin graft, it was not so, doesn't work well, but the people didn't know whether this is immunological or not. And then Peter Medawar he was the first to show that it is really immunological. If you make a histology of the skin, and then you see a lymphocyte invading and then rejecting the skin. So then he thought that how make the skin grafts tolerant or accepted. So he started from the real urgent need and then to basic science, immune tolerance. So that is something in medicine. Sometimes when I give a lecture to students that, you can have a very good hint or something insight from the real human disease. And then you can make it more kind of abstract or define to the theme of research in academia. And then, as you said, the application from that kind of academic research to real clinic or medicine. So 2 ways. People say bench to bedside or bedside to bench. 2 ways. Now I think that it's a good time to do both. That's my always telling the student.
I liked the camaraderie and the teamwork that you found in companies. Most of my good friends in science are still academics. So I walk on both sides of that street pretty comfortably. But in academia, it is very much about what you want to do and your ability to get things done. And it is, I don't mean any disrespect to all my colleagues, it's a pretty egotistical profession. If you're good, you will be successful. And there are lots of them who are very good. Being in a company, you have to set that aside. You're never going to get credit. Well, with notable rare exception, you are not likely to get credit for things that you do to the same extent. But you have the opportunity to make great impact. So when I went to Immunex, which was in the early 90s, the molecular biology team was amazing, and they were much better than I would ever be. The biochemistry team was amazing and much better than I was ever going to be. All the supporting technologies and capabilities there could allow us as a group of people to make amazing progress. And if you looked, at that point, we were trying to clone genes. We still didn't know what they were. And we and other companies, DNX, Zymogenetics, Biogen, there's a handful of other companies cloned most of the things that we now use in immunity to understand how the system works. We are the people who cloned and identified what went with what. And it wasn't done in academia. Some were. A lot of the biology subsequently was sorted out in academia. But we really did a lot of the work because we built a machine to do it. And it was really rewarding, and it was really fun to work with these teams. I didn't have to be the smartest person in the room. I just had to be smart at what I did. And there were other people who were really smart at what they did. That was really fun for me.
I suppose what people sometimes say is that in academia, in theory, you can pursue your own line and nobody's going to stop you. In industry, there are other decisions to be made around you, but that doesn't seem to have impeded you.
Well, it did at times. So that's absolutely correct. So in academia, you can do what you want as long as someone will give you money to do it. So there is that, right? So you have to convince people at the NIH or whatever nonprofit you work for that your idea is worth funding. And, right now, less than 10% of grants get funded. Well under 10% get funded. So there is that challenge in academia as well, right? There are a lot of great ideas that don't get funded. And there are some crazy ones that do. But that's okay. That's all part of the system. It is true that in companies, decisions can be made for reasons that have nothing to do with science. I remember at one point working for a company, I can't remember what company it was, that said, we're no longer going to work on Crohn's disease. Crohn's disease is not going to be a problem. We've sorted that out. That's not true. This is 20 years ago, so that wasn't true then. It's still not true. But I was working on a program that was related to Crohn's, and people came and said, oh my God, aren't you depressed? And I said, no, we've moved on to other diseases. I work on what controls T cells. The disease is, I'm not going to say irrelevant, but it's not the driving factor for me. It wasn't the thing that made me want to study T cells, because I knew T cells controlled a whole bunch of diseases and a whole bunch of biology. So that didn't bother me. However, 5 years after we identified FOXP3 and we published all these papers, our entire site got closed down and we all got fired.
Yeah.
So at that point, you're like, well, I guess I'm not going to work on this anymore. And so you have to go find another job and work on something else. And it's a door closing, a door opening. But, I'd spent 10 years in that room. And it was frustrating to have to go do something else.
It's an illustrative contrast there that you did work at that company that, in the end, was rewarded by the Crawford Prize and now the Nobel Prize, and obviously has influenced the course of immunology very greatly. But the company itself didn't survive. So, no. It's not all about the science.
It's not. But I will tell you the biggest, I don't know if it's regret, but the thing I guess I miss the most about being in a company and not being in academia is students or the lack thereof. So I've had a few postdocs, et cetera. I've taught in courses with students and things. I'm not unaware of the student experience, but I don't have a history of having grad students start in my lab and finish in my lab. I don't have that. I don't know if legacy is the word I want, but I don't have that level of energy and that experience. It's not the getting fired part and the having the projects move away from me part that actually I find disappointing. It's the lack of engagement with students and postdocs. I think the academic question versus the science question really depends on motivation. If your motivation is, I'm going to say personal, if it is such that you feel really passionately about a thing, academia is a much better choice. If you, at some level, I think, want to contribute to and be part of something that could be bigger than yourself, I think in many respects, being in a company is a better choice. No one in academia this will be wrong in the specific, but rarely in academia has anyone ever made a drug that treats anybody. It's very rare.
Yeah. And in both careers, at least in your case, it's driven by a need to understand. So the curiosity is satisfied wherever you are.
You can absolutely have the curiosity satisfied anywhere you want to go. And ability to influence and drive decisions and control, to some extent, how you execute on that curiosity can happen in either place. Or it can not happen in either place depending on how successful you are. But the possibility is there in either way.
Fred Ramsdell's talking about the differences in research cultures in academia and industry. But what about differences in research cultures in different countries?
That's something that I think is very interesting, but isn't very much talked about. Two reflections on this. One might be that the rise of English, if there are such differences, could help dampen it. And I've heard that from some people, that, if there's a particular flavour to the way you communicate ideas in for instance, Japanese or Spanish or whatever language, then does the fact that everybody is being pushed towards communicating in one language, English, mean that you're losing something? It's possible. Hard to know, but entirely possible. The other thing is, I think the national characteristics or what we value nationally must in some ways play out in the lab. Japan is an obvious place to look, thinking about Sakaguchi, because there's a sort of respect for learning and there's a respect for sticking with something. And so it strikes me that quite a lot of the stories of successful Japanese scientists are that they had the possibility of just really exploring something very thoroughly for a very long time and not being encouraged to stop doing that. You can think of other more fast-paced countries where people might get a bit frustrated after a while, start, come on, shouldn't you be moving on? And I do think that there are national differences in the way that certain aspects of research are promoted or approved of or whatever. There's so much to think about when one thinks about what it takes to create a research culture. So many different aspects one could do. I'm sure people are doing doctorates on this.
I thought it was so interesting because there is a part of the conversations in this podcast that we had to take out because of time constraints, where Sakaguchi talks about how Japanese scientists used to name the monkeys that they were working with, that it was very important in the research that they followed this specific individual in a way that sounded quite foreign to maybe other cultures.
Well, maybe if nobody is doing the doctorate, you should do the doctorate on it. You've got time on your hands.
Absolutely. Any time now.
Actually, I quite like the idea. I think it would be a difficult one to finish. But,
ongoing.
As we're hearing a lot these days, a research culture takes a long time to build up a national research culture, but it's an easy thing to tear down. So one should think about all aspects of culture and how to preserve them. I actually asked Shimon Sakaguchi to describe what he thinks is the particular Japanese approach to science.
I think what is important is tradition of research and then also tradition of way of life. Still, I think that the way of thinking, what is important, and tackle with it, and then patiently, it may take time, just continue and enjoy the gradually, even to slowly, we know something better. That's something we like. And still we have that tradition in all the universities. But I'm not sure, it may change soon. But the people think that basic research is important. For example, in Nobel Prizes, so far the theoretical physics, Japan was very good at that from many Nobel laureates all in physics. And many are theoretical physics, just some paper and a pen, and then think about something. And then people really admire them for their accomplishments and the way of their life as scholars. So that is important. People think that they are not rich, but devoting themselves to such scholarly works. So that kind of atmosphere still in Japan, I do believe that it is important.
So the public appreciation of scholarship is still strong in Japan, because worldwide there's a celebrity culture which people find very attractive, and it's nice to hear that there's still a deep and pervading appreciation of scholarship and the gradual flowering of knowledge.
Yes. Well, for example, Japanese royal families, emperor, for example, they are not expected to do some humanities, something, study humanities. But then, for example, the former emperor, he was a botanist, and the previous one is, again, botanist. So the people think that the emperors or royal families, they are engaged in studying natural sciences. That is something, it forms a kind of atmosphere, the society, that sciences or studying natural sciences, that's something good.
When you were growing up, you grew up in a rural setting, and the appreciation of nature around you, has it played an important part in your makeup?
Yes, I do think so. I grew up in rural area, and so if I'm compared with the kids in the cities, maybe not so much sophisticated, but exposed to nature, whatever it is, the insect gathering or whatever, that's something we were very much engaged when we were kids. So I can't tell how it's contributed to my way of science or not. But to directly look at the nature, that is something important. When I was a kid, and then a school asked me as a kind of homework during the summertime, something you must do some experiments or observations in nature. What I did was to measure the cucumber every day, and which part of the cucumber grows faster than others. So I measured. So that was my first report in elementary school. So that kind of experience, perhaps it's maybe contributed somehow the way of thinking. It's hard to tell, but it is important, I believe, to expose to nature directly.
It's hard to tell, but I love that story. And it's observing, measuring, looking, thinking.
Mm-hmm.
Yeah, as you say, not deeply sophisticated, but in a way the foundation of everything. So goodness, from those cucumber measurements to the discovery of regulatory T cells and all that has followed. My goodness, it's a lovely story.
Do you enjoy being out in nature, Adam?
Yes, very much. But then I think most of us do. Mm-hmm. I suppose all of us enjoy nature in our own ways, though. My uncle was a vet. Mm. And the first time he met my partner, he sat down next to her and his opening words to her were not, what do you do? Or even, how are you? His first question was, so, what part of the natural world are you interested in?
How did she respond?
I think rather lamely, she thought, oh, my goodness, and she said something about liking birds.
Don't we all?
Yes, don't we all? It does put you on the spot,
yes.
Unless you've got a passion for something in particular and that it comes into your mind at that moment. And that's a bit the situation I'm in now, because I like so many things about it, but if you had to pin me down, I like shape and rocks. Mm. I like observing geography and geology and the way things have appeared and what's happening and trying to understand what I'm looking at. And I think that we all probably approach nature in a different way.
It's so interesting to sort of think about how that answer would say something about you as a person, because I like just to go find things to eat. Like foraging and berry picking and all that. Maybe that says something quite mundane about me. But
not a mundane at all. Very practical. You'd last longer than I would. I won't get very far with my rocks, will I? Suppose I could build a shelter. And then we could eat your food. It would be fine.
But do you think Nobel Prize laureates are overrepresented as nature lovers?
Many of them have nature as a big part of their sort of learning. Mm. And again, I think we probably all do. The thing they have that is a little different from most of us is that they have this particular sort of curiosity. Often their exposure to nature made them ask questions. So they'll often say things like, I wanted to understand why this was the way it was. Mm. We've mentioned it already in this podcast, but Bruce Beutler, as a boy, was taken for walks in the forest. I remember him saying that one question that he asked his dad was, how come the trees on the ground are rotting, but the trees that are still standing are not rotting? Mm. That's a good question.
Absolutely.
And I never thought of asking that when I was young. I just liked to climb trees and smash up rotten wood. So in those who have the mind to be that sort of explorer, nature is a good source of questions.
This year, we had a world-famous nature lover after the Nobel Committee tried to reach Fred Ramsdell. What happened?
Yes, he missed the call because he was off with his wife walking off-grid in the mountains of Wyoming. And it was only some considerable number of hours later that they found themselves within reach of a cellular signal. He was walking the dogs and she checked her phone because she got signal. She found an enormous number of text messages and she shouted at him. And he thought the shouting meant that he should be worried because there was a bear on the way. So let's hear him talk about what nature means to him.
So I grew up camping, backpacking, hiking. I was in Boy Scouts. But I was only in Boy Scouts so I could go backpacking once a month, and usually for a month in the summer. And to stay in Boy Scouts, you had to get one merit badge every year. I got exactly one a year. I got just enough to stay in. It wasn't that I was interested in most of what scouting was about. And scouting is fine. It didn't disinterest me, but it wasn't my focus. My focus was to be able to go backpacking and to get out. I love being out in nature. I love the birds, the animals, the solitude, the quiet, the lack of people. I spend a lot of time not on hiking trails, but off, not just off grid, but off trail. Right. So I will go orienteering and just get out. We go snowshoeing in the winter. And the great thing about a snowshoe is you don't have to have a trail. You just have to have snow and you can walk anywhere. So I love being out in this environment where my mind is unconstrained by a lot of external input. And I can be with my own thoughts. And I'm okay with that, actually. So I've always enjoyed that. And I still do. And so it's just really important to me. I don't think of it as detox from all the rest of this because I've been doing it since before the word detox was invented, I think. So, or at least digital detox was invented. So to me, it's just part of life. It's not work-life balance. It's just part of life.
That's very key. It's not lifestyle. It is life.
Exactly. For me, it is. Right.
Apart from talking about the beautiful science that led to the discoveries that led to the Nobel Prize, is there something in particular that you want to champion, given the fact that people will listen to you?
I think one area that I'm particularly attracted to is interacting with young people who are interested in science, but really interested in anything and sort of talking about what it takes to be really good and happy in what you do with life. And so I find that, I get a lot of invitations from various, school groups or, whatnot. And I find that that's something that touches my heart. I would like to be an inspiration or a role model for young people, and especially in science, and especially young women in science as well. I certainly owe a ton to the women who have come before me and shown, real leadership in science. And so I would like to carry on that tradition. And then the other thing, of course, that I feel pretty strongly about is the importance of keeping science forefront in society. So funding science and making sure that it doesn't lose its important role in the world. As you know, of course, in this country, it's struggle, and there's a lot of uncertainty as to where things are going and how we can stay strong in the field, in various science fields. So I haven't figured out exactly what the proper platform is in that area, but it's certainly a topic that I would like to somehow champion and be part of whatever is needed to keep science in the forefront. And a lot of it, I think, has to do with figuring out, scientists really need to figure out how to communicate effectively to the general public, because, the politics are responding to the public. And so the public needs to see the value in science. It's not going to help scientists to just go to the politicians and beg for money. It needs to be a kind of a universal value, I think, in society at large. Yeah. And if we're not communicating the importance, then that's a problem that I think the scientific community needs to deal with.
To quote Spider-Man, with great power comes great responsibility. How do Nobel Prize laureates generally react to this side of the prize?
An interesting question. Do you think Alfred Nobel wanted it to create great power? That didn't seem to be his intention. He wanted people to have the money to get on with their research and just not be bothered by having to go out and get funding, as far as we understand it. I'm not sure he meant to create icons of these subjects that were striding the world, giving their verdict on things.
Well, I'm guessing if you have a voice in society that's been amplified like that, then that is power in the 21st century.
No question about it. I was just reflecting on how things have turned out. I wonder if he'd be surprised. Anyway, yes, well, all sorts of different ways, of course. The Nobel Prize laureates are a very various bunch. And that's something very important to bear in mind. Most of them are already spokespeople for various things they believe passionately in, not least the value of funding fundamental work in whichever field it is. This perhaps gives them a slight amplification of a voice they were already using to send that message out. The nice thing about it is that if they have good things to say, it does attract attention, the fact that they have the Nobel Prize. So they can use it to get the message out louder. The trick for them is to not get distracted by all the requests to do things that are not sort of central to what they're really interested in doing or the main message. And it must be very difficult when suddenly you're, in most cases, of course, some of them are so famous already, if you think of Bob Dylan, I think it made a lot of difference how many people wanted to talk to him. But for most, it means that suddenly they have so many more calls to get involved in things and to be speaking out on things. They have to spend time thinking seriously about what they want to devote their time to. Some of them really ignore, to a large extent, the chance to use that side and just continue to do what they did well before.
So it is a choice then?
It is a choice. You can choose, of course, how much to use it. But the question was, how do laureates generally react? Might be a one-word answer to that. Generally, well. The reverse is true, but not many.
You also asked Fred Ramsdell how he feels about this new role going forward. Let's listen.
You've taken on this mantle of being a Nobel laureate, which I guess does interfere in the day job. What do you want to do?
So I don't want a day job. So I'll start with what I don't want, which is a day job. I've spent a lot of time building teams, companies, scientific programs, some better than others, some successful, some less successful. It happens. Other people can do that. They're probably better at it than I am at this point, and I will let younger generations take that mantle on. What I think my role now is, some level, is inspiring youth, younger people. It is, I don't want to use the word wisdom, but providing old guy perspective. So I don't like the idea that people don't understand what has happened before, because then you make mistakes. If you don't understand history, you're doomed to repeat it, kind of thing. So I think providing perspective on what people have tried, what's worked, what hasn't worked. I know a lot of things that don't work that's never been published, just because I've been doing it for a long time. So when I see people trying to do something that has been tried by very smart people and not worked, my response is, how are you doing it differently? What makes you think this is going to work? And you may not know it didn't work. So let me give you that perspective on why this didn't work. So I think it's really one of providing old person perspective to people who are enthusiastic and smart, and in some cases brilliant, but don't know history to the extent that I do. There's this line of, you don't want history to constrain people. I don't want people to think, well, that can never happen because. But, so maybe it can, but at least go in with your eyes wide open and understand what the challenges might be. So that's the kind of thing I want to be able to do over the next X number of years, is provide that perspective on what history is, and really also a little bit on what I personally think might be important going forward.
I'd just like you to reflect a little bit more on what it takes to make a good partnership, because so many young people ask about collaboration and they just don't know how much to share, how much not to share, how much to work, be an individual in a collaboration, how much to give away. It comes up all the time in our discussions, and you have been fantastically productive collaborators. And so what would you say it takes to work well together?
I think part of it is really having an appreciation for what you're good at and where your strengths are. And it's a no-brainer for me and Fred, because our experience is so different. I couldn't pretend to do what Fred does, and vice versa. Or, our teams, we're pretty non-overlapping, but very complementary. And what I see when I, talk to people about this idea of how much do you collaborate, I have a fair bit of experience, talking to people who are in a more academic environment, where I feel like there's a little bit more of a, protective cocoon you build around your own enterprise. And if you want to do a big project that needs a lot of different expertise, you'll try to bring it more internally into your own group rather than collaborate. There's a lot of really productive collaborations as well, but I feel like given the funding and publication pressure and all that kind of thing, it's better for a PI to have a bigger piece of the project. But at this little biotech company, the company wasn't going to succeed if we didn't all just work towards the goal. And I think there was a lot less emphasis on sort of personal success or, success for a particular team as opposed to another team. We all had to go for the same goal. That was my experience.
Yeah, that alignment and motivation, I think, is really helpful. I think the other thing, then I think it takes time to build this, but you have to trust the person, right? And I think Mary and I trust each other. We have for a long time. We did during the process, again, in part because she was good at what she did. I was good at what I did. And we had great teams that would help us accomplish things. And so there wasn't ever any question of ability. So you just trusted each other implicitly, but also in their abilities to do what we needed to do. It might work out, it might not, but we trusted we would do it to the best of our abilities and we'd get through it one way or another. And I think, as Mary points out, that's difficult to do without having a strong relationship with people.
Lovely. Thank you very much indeed. It's a privilege to listen to the two of you talk about that time.
It's always fun, Fred.
Always.
I like sitting with Fred.
Yep.
Yeah.
It is always a pleasure to talk with Mary about this stuff. So.
Thank you very, very much.
Well, you're very welcome. I enjoyed this conversation very much.
Did you enjoy these conversations, Adam?
I did. It's nice to have the chance to speak at greater length to these people. Those conversations that we record back in October, quickly, when they've just got the prize, are nice and sort of breathless and fun. But it is nice to have a more sensible conversation with people with a bit more time to spare.
It's nice to listen to them too. Thank you for this one.
Thank you. It's always nice to speak to you too. We need to go off into the wilds and build our house and eat our food.
If you'd like to learn more about the 2025 Medicine Prize, don't miss this episode's show notes. There we help you explore the science and the minds behind the medals with articles from nobelprize.org. You can also relive the excitement of the prize announcement or the pageantry of the Nobel Prize award ceremony in film clips from our YouTube channel. Don't miss it. Nobel Prize Conversations is a podcast series with Adam Smith, a co-production of Filt and Nobel Prize Outreach. The producer for this episode was me, Karin Svensson. The editorial team also includes Andrew Hart, Olivia Lundqvist, Monica Miller, and Simon Doyle. Music by Epidemic Sound. You can find previous seasons and conversations on Acast or wherever you listen to podcasts. Thanks for listening.